In this video, we are going to look at several truth table examples, or examples related to logic and truth tables. So here, if we're certain the statement P or Q is false, and we also know that P is false, what could we say about Q? Is Q true? Is it false? Could it be either? So what we're thinking about here is we're thinking about just the truth table row where we have P, we have Q, and then we have P or Q. We know that this is false right here. We know that P is false. So when do we have P or Q being false? What needs to be true? So it is false if both of them are false. And so we have to have Q be false as well. So we can say with certainty, this is false. Now, if that would have been an and right here, if we would have known that P and Q is false, and P is false, and we also knew that P was false, then we couldn't actually say anything about Q, because for the conjunction for and, it is false if either one of the two pieces is false. So if we knew P was false, it wouldn't have mattered if Q was true or false if the other piece was P and Q is false. All right, great. Next up, we have let P represent a false statement. Let Q represent a true statement. We're going to find the truth value of the compound statement, not P and not Q. So we know we are starting with P is false. We know Q is true. We're going to see what we can say about not P or not Q. So we need to find the value of not P. So not P is going to be the opposite of false, so it's going to be true. We need to find the value of not Q, which is the opposite of true, so it is going to be false. And then we need to find the value of that disjunction, not P or not Q. So we're going to look at these two columns. So true or false, it will only be false if both pieces are false. So since at least one of those two things is true, this will be true. So we can find that without too much issue. All right, let's keep going. Let's look at another example. Let's let P represent a true statement and Q and R represent false statements. We're going to find the truth value of this compound statement. So we know P is true. Q and R are both false. Q and R, those are both false. So we're not building the whole truth table, just one piece of that truth table. And so we're going to build all this out. Let's first find the stuff in the parentheses. We have Q or not R. So first we need to find not R. So not R is going to be the opposite of the truth value for R. Then we need to find the truth value for Q or not R. So Q, false or true. False or true, those combine to give us true. It will only be false. An or statement is only false if both pieces are false. And then, I won't rewrite this since it's nicely right here, but we have all of it put together. We have the stuff in the parentheses, right? This right here. So true and P. So true and true. Since both of those are true, true and true, this will give us a truth value of true right here. Excellent. Good. So 2 more examples and then we'll call it a day. So let's give the number of rows in the truth table for the compound statement shown below. So here we're not building the whole truth table. We just want to determine how many rows is this going to have. Right? And so to determine how many rows, we need to see how many arguments do we have. So we have P, we have Q, we have an R, we have an S, we have another R, but that's not a new letter. So we have 4 distinct letters, 4 distinct statements that are then going to work together to make this giant compound statement. So we have 4 statements. So then the number of rows is 2 raised to the 4th. So it's 2 times 2 times 2 times 2. So not 2 times 4, but 2 raised to the 4th. And so that is 16 rows. And then finally, we are going to use De Morgan's laws to write the negation of this statement. I am not going. So we could say statement P is I am going. So this is not P. Or she is going. So statement Q, she is going. So we have P or Q. We want the negation of that, so we are going to negate that entire statement. De Morgan's laws tell us when we negate that, we're going to take the negation of each piece, but that or will change to an and. When you negate a negation, they just undo each other, so we have P and not Q. So we would say, in words, I am going. And she is not going. Perfect. So that is our introduction to truth tables. All right. Have a great day.